In our last video, we learned the basic idea about what density is. We learned that density has to do with how close together or far apart the particles in something are. Objects like this rock have particles that are closer together, making them more dense. Objects like this styrofoam have particles that are spread far apart with lots of space between them, making them less dense. Well, that's the big idea about density. But what about the density formula? If you're like a lot of people, when you hear formula, you think, man, that just doesn't make sense in my head. It's kind of like magic. If you put in the right numbers, maybe you'll get the right answer. I want to show you that the density formula actually is extremely practical. It makes a lot of sense in the real world. Let's just say that I wanted to compare these three different types of matter, and I wanted to be able to assign them a specific number for their density. Well, let's imagine first of all that we lived in a world with no math. No math at all. What would I do in order to compare the density of these three objects? Well, if you're anything like me, the first thing I would think is they're all different sizes, and that makes them really hard to compare. But what if I had a certain size, a standard size piece of the styrofoam, the rock, and the wood, so that I could easily compare those standard or equally sized pieces? Well, if we're living in the world with no math, how am I going to do this? I've got an idea. Well, that was a whole lot of work, but I did it. I managed to cut the stone, the wood, and the styrofoam each into an equally or standard sized block. Now I chose a cubic inch. An inch, that's a cube, a three-dimensional inch. Because that was a size that worked well for me, and I'm American, so inches are kind of common. But I could have really used any standard size. Now that I've got them in a standard size, it's so much easier to compare. Just by feel, I can tell which one has the most matter and which one has the least. But in science, we strive for precision. We want to be able to assign specific numerical values, a specific density number for each of these objects. So, in order to do that, now that I have a standard amount of volume, or space, I can find out how much mass or matter is in each of these objects. So I did it. I have calculated the density of these three objects and all without using the formula. I have found the density of my styrofoam is 0.3 grams of matter per cubic inch. The density of this particular sample of wood is 10.8 grams per cubic inch, while the density of my stone is 31.2 grams of matter per cubic inch. That's right, I got a certain set volume, and I found how much mass is in that certain standard. Wait a minute. The density formula, D equals mass divided by volume. You know what? That formula could have done all that work for me. If I had just taken the entire object at the beginning, I'm gonna have to put this back, and I had found the total mass and then divided it by the total volume, that should have given me the same answer and saved me a whole lot of time. Let's see though if it really works or if it's too good to be true. I'm gonna test this out. .29 grams per cubic inch. Almost identical to what I found when I did this the hard way. 0.3 grams per cubic inch, 0.29 grams per cubic inch. Differences like that are so small that surely it's just due to my imperfections in cutting, measuring, or other experimental error. So there you have it, the density formula. Nothing to be afraid of. If you can find the total mass and the total volume of any object, you can find out how much matter is in one standard unit of that material. And that's what density is. The formula is simple, it's profound, and it works, and it saves you a whole lot of work. So, keep on learning and stay curious, my friend.